Okay, I think we're recording now. So I wanted to, first of all, welcome you to this live online session. Even though we're not meeting in live setting as we normally do, I still wanted to do a recording that's available for you should you wish to look through it, kind of capturing those big themes of this week's topic. So we're approaching towards end of the semester, and as such, we have a few more chapters to go through. And in this week's materials, we're looking at our peripheral nervous system, and we're also looking at our autonomic nervous system. As always, I do have a little bit of a plan of what I hope to cover on this particular session. So we'll just start kind of outlining what's the expectation this week. We have few changes from the normal. I also want to kind of touch upon few points that came up on our midterm feedback, and then really kind of outline what are the assignments that we're doing this week. You will see that the workload tends to get a little bit lighter as we approach end of the semester, and that gives you a little bit of room if you need to go back to any of the assignments or want to do additional assignments to get your grade where you want it to be at. I also have on the objectives just a kind of a quick reminder. I don't have a full-on slide about that, but remember that next week is going to be our final week together. So if you're running behind on assignments, if you need to do other things, this would be the time to start thinking about how we can get those in. And if you need me to reopen assignments, I'm happy to have those dialogues. But remember, once the semester is over, unfortunately, that's when I have to start to draw the line that I can no longer accept new assignments. The bulk of this recording, as usually, I was planning that we'll spend on reviewing the key items from the chapter 13 and chapter 15. As always, I do want you to know that I'm here to help you. Even though this is an asynchronous course, it doesn't mean that you're without assistance. So since we don't have this normal synchronous live online session, don't hesitate to message me if you have questions or if I can provide any additional materials or additional information. So talking about this week and how it's a little bit different, I wanted to be, again, I think I've mentioned this before, super transparent that since I am traveling for work, there is some limits to the amount of connectivity that I have available. I'm pretty much booked from early morning till late night, but I will make sure that I try to respond to messages once a day. That excludes the Friday, which is the day when I'm doing some further traveling. So unfortunately, I'm not going to be available during that time. Having said that, though, I know that it's taken me a little bit longer than normal to respond and get back to messages that I have received during this time. First with the family medical emergencies and then being on the road. So if you have not received a message, please let me know, because I do think that I should be pretty much up to date of getting back to everyone who I promised to get back to. So if you haven't heard back from me and you're expecting to hear back from me, it has somehow fallen off from my radar. So please don't hesitate to resend that message and we'll get that taken care of right away. So as always, remember, my role is here to be here to help. And if you don't hear from me, don't give up. That doesn't mean that I'm not interested to help. It simply means that somewhere along the way, the message has gotten lost. I also wanted to share really quickly a little bit of a video to give you an idea of where I'm at, even though it's not my work, but some of you might find it interesting, especially based on the discussions that we had last week. So part of the reason why I do love doing science is that we get to constantly learn, and I'm currently at the place where a lot of research, especially in the neuroimaging field, is happening. So what you see on the screen is the brain of a zebrafish, and you'll see how different areas are active as it's swimming along and it's doing different activities. So I think it really speaks to some of the structures, some of the concepts that we've been talking about. You'll see that certain areas are constantly active, other areas get activated as they are needed. So interesting things to keep on mind if that's something that you're interested in. I also wanted to briefly address the midterm feedback. It seems that we're on a right path. We're doing rather positively. So I appreciate everyone who shared their impressions and kind of helped me to charter where we're at. There were a couple of very, very good points that I wanted to spend a little bit of time. And by no means, if I'm addressing it, it doesn't mean that I don't believe or I don't agree with you. I'm just trying to find solutions to themes that might have come up. So one of the comments that came true is that I first of all totally understand that last week was very hectic. We covered a lot of material, or the week before that, to be honest. So I'm always doing changes on my schedule for the coming semesters based on the students' feedbacks. I do want to though also kind of give a different perspective that remember that this is an accelerated class. We're covering in 8 weeks everything that we would typically cover in 16 to 18 weeks long semester. You do have an option to work ahead of the schedule. You might not get your assignments back as fully graded if you do them very far ahead of the schedule, but you definitely have that option if you know that you're busy at certain time. There was also a question about the kind of end of week due dates that might feel a little overwhelming. I do put the due dates at the very end where I can put them, so I don't put them earlier than where they need to be. But nothing prevents you from managing your time independently and maybe setting a goal that you try to cover one chapter by Tuesday or Wednesday of the week, and then a second chapter by, say, Friday or Saturday. And that gives you that one day of kind of having a breather or doing exams, doing tests, whatever comes up. So remember again, we are learning definitely content, but we're also learning skills to manage your time. We're learning skills to navigate the college level courses. Another theme that came up, and I totally understand where it's originating from, is that sometimes there's a lot of names, sometimes there's a lot of terms that you're covering. This is again where I encourage you to be creative. There's a lot of great resources being shared on the discussion forums. I think students are often better at finding the newest things than I even am. And I also share quite a bit of materials on our Canvas course as additional handouts. So these are all the handouts, these are all the materials that I would share with my face-to-face class. So I want them to be available for you. So if you're a person who finds it helpful to label things, color things, I also shared that anatomic coloring textbook, which some of you have found useful. Please consider doing so. Again, I'm not collecting them back. They're not assignments that you need to submit to me, but I want to show that there are multiple types of resources. So again, kind of find what works for you and capitalize on that. I don't think this came up a lot, but since it was mentioned at least by one student, I wanted to make sure that if there's ever any technical issues with your publisher's homework platform, please do not feel that you're stuck with it alone. I'm here to help. And also the McGraw-Hill, which is the publisher that runs the Connect, has an incredibly good IT help desk. If you go to their help desk, it allows you to kind of direct you to what resource you're using. And they have a team that's available pretty much throughout the week on most of the days and very extended working hours. So I encourage you, if there's a technical issue, to rely on that. If there's a content issue, you can contact them or you can contact me. Also, do remember that I would not recommend leaving the homework, especially important exams, to the very end of the week. Nothing prevents you from working a little bit ahead of the time, just in case if there's any technical issues. I will be honest, even though I'm super responsive, sometimes on Sunday nights around 12 o'clock, I do go and have some sleep. So if you message me at the very end of the week, it might be that it has to wait until Monday when you hear back from me. Having said that as well, do remember that my teaching philosophy is to see you be successful. So if you need extensions, if you have situations that come up, I will be more than likely willing to discuss and figure out what we can do to help you. So that covers all that I had about the midterm feedback, but most importantly, again, thank you for everyone who shared their ideas, comments, and ways how I can keep improving this course. So what we're doing this week as homework, we're looking at 2 chapters. We're looking at chapter 13 and chapter 15. For chapter 13, I have your typical quiz, your practice anatomy assignment, and then I have our discussion forum. This week's discussion forums are completely student-driven, so I'm asking you again to do 2 posts. One of those posts should at least contain questions. So those prompts that I normally provide to you, that you present to your classmates, and one of those posts should be a response to at least one of the prompts. In this case, that would be presented by one of your classmates. So you'll see that my discussions kind of build what we're doing, you're getting hang of it, and then we add another element. So it's we're moving to the point of the course where it's led by student and driven by students. I will be still checking in, I will be still participating, I will be still answering, but I really encourage you to kind of think of also from point of view of a teacher, what would I want students to demonstrate that they have mastered? And for the chapter 15, we also have a quiz. I do not have a practice anatomy activity for chapter 15, and then I do have a discussion forum for that. I realize that I have not changed the chapter number there, so let me just rectify that quickly. So that should be the homework that I'm asking us to complete. And remember that I'm asking those homework assignments to be submitted by the end of the week. So Sunday night, 1 minute before midnight is when those close. But again, I encourage you to work a little bit of ahead of the time and being proactive in those. So let's have a look at the actual chapter content. I do have a lot of slides this time around that I'm keeping on eye of my other commitments, so we might cover every single finer nuance, but I think that this provides you a nice nutshell version of what's important. So in chapter 13, we're starting to kind of with the focus on peripheral nervous system. And here we have this very nice diagram that kind of puts things in perspective of nervous system and how we can divide it into different sections. So kind of helping that where does this chapter belong in that bigger picture. I do want to though highlight that there's a lot of interaction between central nervous system and peripheral nervous system, messages traveling from peripheral nervous system to central nervous system and the other way around from CNS to PNS. So there's a bunch of material to go through. In terms of the peripheral nervous system, we're looking at all the neural structures that are located outside the brain and the spinal cord. So we'll talk about things like receptors, nerves, motor functions, and reflexes. So what I wanted to show here is that we have in the peripheral nervous system some information being brought in, as you can see on this diagram on the spinal cord. So these branches, this information is known as afferent information, afferent branch. This is typically sensory information that's arriving to the nervous system. And similarly, we have information leaving the nervous system and central nervous system through the peripheral nervous system. So information that's passed away. This is typically motor information, and these are known as our efferent nerve fibers. So you could kind of think of these that we have the sensory information going in at the dorsal root of our spinal cords, and then we have the motor information leaving the nervous system, central nervous system, through a ventral route. So again, those terms that you learned early on this semester, remember dorsal towards the back, towards the spine, ventral towards the belly side. So I hope that you're seeing that all of these things kind of add up together and make sense. I also wanted to talk a little bit about receptors. So what receptors do, they collect information and they respond to changes in environment. And they are playing important role in that sense. In order for us to have receptor triggering a sufficient stimulus, we need to produce the action potential. And that was the topic that we kind of unbundled in a great detail. So remember, again, we do analyzing of the messages, analyzing of the information at many levels, so that whether the action potential was triggered or not was happening at the neural level. But the other thing that I wanted to mention here is that remember that not all information from receptors really mean anything until it gets to our brain, to the level of the brain. So we only become aware and give meaning to the stimulus once that information has reached the central nervous system. And this brings me again to this diagram that we've seen time and time again. So we're seeing that in kind of homeostatic feedback mechanism loop, the sensory receptors fall into that second stage of the process. So we're kind of focusing now on the receptors. Last week, we focused on the control center. I also wanted to talk a little bit about 5 types of receptors if we're grouping the receptors based on the type of stimulus that we're dealing with. So mechanoreceptors are dealing with touch and other forms of it, whereas thermoreceptors are dealing with temperature. Photoreceptors instead respond to light energy, so dealing about things to do with vision, and remember where it's all about sensing shapes, sensing colors, things like that. Chemoreceptors are a group that covers a few different senses. So we have our smell, we have our taste, and we also have chemistry, for example, in terms of monitoring the blood content as an example. And then we have our nociceptors. These are to deal with pain, and it can be an actual or simply a threat of tissue damage. But there's other ways of classifying receptors as well. We can classify receptors based on location, whether it's inside or out, kind of on the outer parts of your body, or we can classify receptors based on its structure. So we have very simple receptors, and then we have our special senses, and we'll talk about those next week as we're wrapping up this material on nervous system. Other thing that I kind of wanted to mention is that this information is now moving from the receptor to the brain, and it's at the level of the brain where we're starting to give it meaning. So let's have a look at 2 types. Sensation refers to the fact that we're aware of a change that's taking place, whereas perception really is giving it meaning. And these both processes are taking place at the level of the brain. Here I have a rather nice diagram. I'm not going to go too much into that, but you remember from last week, we've now been talking about receptors, and last week we talked about the role of the brainstem, thalamus being important relay stations, and then finally ending up to the primary processing area for those particular messages. In this case that we're looking at would be our primary somatosensory cortex. Other thing that I wanted to talk a little bit about is the concept of adaptation. So if we have a constant stimulus, your body will stop noticing it. Remember how homeostasis was all about detecting changes. So changes are what we're interested in. And you could think of some pathologies in that way as well, when we're changing away from that normal, from that homeostasis. I can offer you a few different examples of this. We see, for example, when you put on clothes, you first start to feel their pressure on your skin, but then you get used to it. Or another good example would be if you're ever washing dishes by hand, the water where you're washing them might feel very warm initially, but then you get used to it. So those would be good examples of adaptation. In the interest of time, I want to mention a little bit about the pain as well. So remember, pain is incredibly subjective. There is no one set objective way of actually quantifying pain. You might see in hospitals, sometimes we ask, or clinicians ask a patient to describe their pain on a scale, say from 0 to 10 or so on, but it is always a subjective experience. So you can't really objectively measure pain. We will actually be talking in our AMP2 class about measuring pain, for example, when giving birth. Obviously, this is just a silly picture, but I guess one of the aspects that I would share, and I never encourage you to do anything naughty or bad, but if someone is asking for sick leave, it is almost impossible to dispute pain, and especially back pains. It is a subjective experience. We can't really quantify it. So you do what you want with that knowledge. So let's unbundle pain a little bit further. Like I mentioned at the very beginning, pain is either a warning of ongoing or potential threatening tissue damage, and pain can result from really anything that could cause damage in our body. Naturally, your body will start to inhibit these sensations with opioids, and we see that we can use this almost also in pharmacological settings. Pain tolerance does vary from one individual to another, but remember what I want my students always to remember when you're going to clinical fields. We're especially worried when someone is not feeling the pain. So, for example, diabetic injuries are a good example of that. These patients often end up injuring themselves because they don't feel that, for example, their feet, if they're in a wheelchair, and they end up doing damage. The healing process is also prolonged, but that lack of pain is what we're worried. Similarly, if someone's fallen over, someone's hurt their back, I would be concerned if the patient says that, no, I don't feel anything, or I don't feel that it's painful, when we know that the injury should trigger pain. So those are some considerations to keep on mind. But also do remember that the pain does not always originate from where we might feel it. And this is the concept of referred pain. So pain from one body region is perceived as coming from a different region. We often see this, for example, in heart attacks, the pain radiating down to the left upper limb, especially on the medial side, also at the level of neck. So really, you've done a great amount of work of learning anatomy, and now we're seeing that sometimes that anatomy and where the patient declares pain are not quite as clear and quite as well mapping. So this is where the complexity and anatomy of nervous system and nerves comes to play. So what I have on this slide is just an image of a nerve. We're seeing these cord-like bundles of axons closed in connective tissue. You can see a microscopic image of a nerve, but also kind of a diagrammatic presentation. Notice the blood vessel within these structures. What I did want to mention from here is that, remember, we have mainly two main types that we'll be focusing on. So cranial nerves, and then we have our spinal nerves. I think that this is a good time for us to briefly touch upon on the cranial nerves. Like I said, I shared a very nice diagram with you on those additional resources. If you feel that going through them by that would be helpful. So what do you need to know? You need to know the number of the cranial nerve, and for numbering cranial nerves, we use Roman numerals. You also need to know the name of the cranial nerve, and you need to know its function. So let's go through those briefly together. So we have 12 cranial nerves, and we're going to start from cranial nerve 1, which is actually the most anterior nerve. So on that image, you're seeing the bottom of the brain. The anterior side would be here at the top and posterior at the bottom of the screen. So olfactory nerve is our cranial nerve 1 and responsible for your sense of smell. In our discussion of the comparative anatomy, we saw, for example, sheep having larger olfactory nerves than humans, if you looked at that sheep brain dissection video that I have prepared for you. We also have our optic nerve, which is our second cranial nerve, that is responsible for carrying the information from the eyes to the brain, so the visual information is passing through there. What I want to draw your attention next is a set of 3 cranial nerves. So cranial nerve 3, which is our oculomotor, our cranial nerve 4, which is our trochlear, and our cranial nerve 6, which is our abducens. All of these 3 cranial nerves are responsible for controlling your eye muscles. nerves. So if you look at it, that out of 12 cranial nerves, 4 are dedicated for the vision. That tells you really how much we rely on vision and how important sense it is for us. Moving further, I jumped over to cranial nerve 5, which was our trigeminal nerve, responsible for things like, for example, controlling those muscles of mastication that you learned about. Then we have our cranial nerve 7, which is our facial nerve. Cranial nerve 7, facial nerve, controls, for example, the muscles of the face. And I do admit that these get small and kind of tightly packed there on the diagram. So again, if coloring, if visual learning is your way to learn, consider doing that. Next nerve that we're going to see is our cranial nerve 8, which is going to be our vestibulocochlear. Vestibulocochlear, responsible for things like your hearing and also your sense of balance. So you'll see again those openings of the skull that we talked about being important. The nerve that we're going to look at next is going to be our glossopharyngeal. And glossopharyngeal is responsible, for example, your pharynx and salivary gland regulation, things like that. The following nerve after that is our vagus nerve, cranial nerve 10. Remember, vagus as a term refers to the Latin word the wandering kind. So we'll see vagus nerve on several instances. One of the functions would be, for example, regulating the swallowing process. Then we have our accessory nerve, which is cranial nerve 11, controlling muscles of the neck and back. And finally, our hypoglossal cranial nerve 12, responsible, for example, controlling your tongue muscles. There are many mnemonics for memorizing these cranial nerves. Some of them are more appropriate for me to share, some less. I'll let you look those up from the lecture videos, but again, I'm sure if you Google, you'll find some very dramatic versions that might be easier to remember, but would be inappropriate for me to share with you in this context. I also wanted to talk very briefly about the structure of a nerve. So we classified those based on the direction where they're transporting impulses. We kind of touched upon onto this earlier on. So we have our sensory nerves that are afferent nerves, bringing information to central nervous system, and our motor nerves, which are our efferent, bringing information away from the central nervous system. We also have parts of the nerve that share both sensory and motor functions. So those are what we know as our mixed nerves. Ganglia is a collection of neuron cell bodies within the peripheral nervous system. So that's going to be an important concept, especially when we're drawing differences between different nerves. And I also wanted to talk a little bit about dermatomes. So these are areas of skin innervated by each spinal nerve. And you'll see that there's a lot of those we can kind of map out the body. Again, this would be if we have injuries, spinal injuries, to make sense out of that. I will mention that there is a small amount of overlap between these as well. If we have a single spinal nerve damage, it probably doesn't cause complete numbness. It does cause issues, but it is those more catastrophic spinal injuries that we're especially worried about. Next thing that I wanted to kind of show up is kind of a reminder of our autonomic nervous system branches of sympathetic and parasympathetic branch. You remember, let's first orientate ourselves with the autonomic nervous system. These were mainly dealing with motor neurons that are responsible for maintaining homeostasis. So we have smooth muscles, cardiac muscle, and glands that are just automatically regulated. You don't need to think about that. That's subconscious. So really involuntary system and really general motor responses. In terms of the somatic nervous system, we're seeing that these are skeletal muscles that are innervated, again, autonomic and under automatic control. We can also draw a difference between somatic and autonomic nervous system on a level of anatomy, not just physiology. So somatic nervous system is made of a single nerve with a single axon with the cell body located within the central nervous system, whereas autonomic nervous system is really a two neuron chain where we have that preganglionic neuron or preganglionic axon, then we have the ganglion where the cell body was, and then postganglionic neuron or postganglionic axon. So worthwhile to notice there. We can also see that there's differences in terms of those neurotransmitters. So we talked about those chemicals that were involved as part of the propagation of messages. So somatic nervous system mainly relies completely on acetylcholine, which has a similatory function, whereas in autonomic nervous system, things get a little bit more complex. So the preganglionic neuron released acetylcholine, whereas the postganglionic releases either norepinephrine or acetylcholine. And effects in autonomic nervous system can either be stimulatory or inhibitory, so a little more complex. Remember that there is overlap as well at the higher level, higher brain centers where we're doing these coordinations. So most of the time we teach you the simplified version, but reality, as we saw with the brain, is much more complex. We're finding ourselves again with this diagram. I think next I wanted to highlight just the sympathetic and parasympathetic branches. We've talked about those before. Parasympathetic division often described as a rest and digest. So focusing on body's maintenance functions, energy, conservation. So things like your digestive system and your urinary system being activated. This was the example that I said, think of yourself after a Thanksgiving meal. We're simply maintaining the body. We can kind of lower our alertness. Whereas sympathetic division was all about these fight or flight responses. So we're now directing resources so that we can deal with that threat either by confronting it or escaping it. So heart rate up, breathing rate up, we're directing blood to skeletal muscles and so on. Remember that all visceral organs are served by both, but we can see a little bit more complexity there. And again, we find ourselves thinking of the concept of homeostasis. So these were the pictures we looked at in our last week's presentation. Finally, some anatomical differences to kind of expand on what you already know about sympathetic and parasympathetic branches. So what we see typically, the parasympathetic branches originate either from cranial region or from sacral region. Sympathetic ones really originating from your thorax or lumbar region of the spinal cord. We see that there's also a difference in the length of the fibers. Remember, this is a nerve fiber or two neuron arrangement. So parasympathetic ones have kind of typically long preganglionic and short postganglionic axon, whereas sympathetic ones have a short preganglionic and long postganglionic axon. We can also think of the location of the ganglia. So parasympathetic nervous system, really those ganglia are located either in or near to the effector organ, whereas on the sympathetic nervous system branch, we see that the ganglia are located at the spinal cord level. Remember, again, we have control on many different levels. We're doing a lot of processing. We're doing analyzing of information. So that's the last week's material that was important there. And I have shared on the remaining slides a little bit more details about the roles of the brainstem and spinal cord kind of interacting. Also the role of hypothalamus that we talked about quite a bit last week, and cortical region. So again, remember, this is kind of a leveled process where we see that the responses really depend on what level we're processing things on. So I think that diagram kind of summarizes it nicely. You can look into it in more detail if you're interested on our full lecture material. And that really brings us to the end of what I wanted to review with you on this recording. As I have said, keep in mind that we're quickly approaching the end of the semester. So we want to start to make sure that our grades are up to date. We want to start to make sure that you are landing where you're hoping your grade to land. And if you're not, then it's time to start to think, what else can we do? So that concludes everything from me on this recording today. Again, I so appreciate the great work that I see taking place both on assignments and on our discussions. And again, remember, my role is to be a resource for you. So all you have to do is let me know how I can assist you. I look forward to seeing you on our online learning spaces. Thank you for joining me.